So now today we have to prove the second question. So first question already we proved yesterday. So the second question is show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5 where q is some integer. So any positive odd integer. So now we have to prove this by using the Euclid division lemma. So what is Euclid division lemma? Euclid division lemma says that a is any integer, then a can be written as bq plus r, where 0 less than or equal to r less than b. So we are going to apply this in this question. Here it is given that q is any integer. So let us take any positive odd integer. So we have to prove that a is any positive integer is of the form. That means a can be 6q plus 1, 6q plus 3 or 6q plus 5. So this we have to prove. So how to prove this? So we have already assumed that a is any positive integer. Now let us take b as 6. Why we take 6? Because nothing, just here bq plus r form. So here it is 6. So just take b is 6. Now what are the possible values of r if b is 6? According to Euclid division lemma, r should not be greater than b. From 0 to less than b only r can be possible. So what are possible are 0, 1, 2, 3, 4 and 5. Because b is our 6, so r cannot be equal to or greater than 6. So our possible are 0, 1, 2, 3, 4 and 5. Now, what are the possible a now? A is this we have to prove only. So what are the possible a according to Euclid division lemma? A is equal to bq plus r. So b is our 6. So first let r is equal to 0. If r is equal to 0, a is equal to bq plus r. b is what? 6. So 6q plus 0, that means 6q. So in first case we got a is equal to 6q. In second case r is equal to 1. So what are a? A is equal to bq plus r, that means 6q plus r is here 1. So a is equal to 6q plus 1. If r is equal to 2, then a is equal to 6q plus 2. If r is equal to 3, then a is equal to 6q plus 3. Now in the next case, r is equal to 4, a is equal to 6q plus 4. Now r is equal to 5, then a is equal to 6q plus 5. So these are our possible a. Now what are the numbers we got? Just write here. A we got 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 and 6q plus 5. These are the possible a we got by using Euclid division lemma. Clear? 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 and 6q plus 5. These are our possible a. Now don't forget that we assume that a is any positive integer. This we are assumed before. A is any positive odd integer. Now what means odd integer? A is odd. What means odd integer? Odd integer means it cannot be written as a multiple of 2. If it is multiple of 2, the number will be even. So check whether any of these number are multiple of 2. Check 6q. 6q can be written as 2 into 3q is 6q. Correct, no? 6q is written as can be written as 2 into 3q. That means it is a multiple of 2. So this is not odd. This is even. So A cannot be 6q. A cannot be 6q. Now take 6q plus 1. This cannot be written as a multiple of 2. Now what is 6q plus 2? 6q plus 2 can be written as 2 into 3q plus 1. So this is also can be written as a multiple of 2. That means this is also even number. So we cannot write 6q plus 2 as A because our A is odd. Now 6q plus 3 cannot be multiplied by 2. Sorry, it cannot divisible by 2. Now 6q plus 4. 6q plus 4. This is also can be written as a multiple of 2. What? 2 into 2q plus 2. So this is also an even number. So this also we can cancel. So rest is 6q plus 5. Here we cannot write as a multiple of 2. So what are the possible A? 6q plus 1, 6q plus 3 and 6q plus 5. So we can assume that we can clear that A is any positive odd integer is of the form. So what are our possible A? 6q plus 1, 6q plus 3 and 6q plus 5 because all other integers are even. So A is odd integer, then these all are only possible A. So what are the possible A here? 6q plus 1, 6q plus 3 or 6q plus 5. So this is our question. What we have to prove? For any positive odd integer is can be written as a form 6q plus 1, 6q plus 3 and 6q plus 5. Hence the proof.